Well, dear students, in last videos I have told many things about radioactivity. So I defined Rutherford-Soddy law, defined half-life period, defined the relation between half-life and decay constant, and then mean life and decay constant. Many things I have told. Try to learn them easily. Don't have any panic that you can't understand. Now I am taking here rate of radioactivity. You have learned in chemistry the rate of chemical reaction. So radioactivity is again a reaction of radioactivity of element. So how do you define the rate of radioactivity of a given sample? Why I am telling given sample? This is important here. I will tell you later. Given sample of a radioactive element is defined as the number of radioactive decays taking place per unit time from the given sample. The rate of radioactivity, numerical defined as the number of decay taking place per unit time from the given sample. Actually, radioactive nuclei are required for activity, and in radioactivity, a radioactive nucleus after decaying becomes stable, or it further give another kind of activity. So as decay takes place, it may become stable or will give another type of activity, like suppose first it decay into alpha, then it may decay beta, and then they may give gamma rays from a given nucleus. All three radiations are not emitted simultaneously. At one time it gives only one emission, either of alpha or beta or gamma. So I told you the rate of radioactivity of a given sample of a radioactive element is defined as the number of radioactive decay taking place per unit time from the given sample. So it is simple definition. Now I come mathematically. If dn, modulus dn, is the number of decays in time interval dt from a given mass, given mass or given sample. of radioactivity active element. Then the rate of activity is given by, I write it RT. T means time. It varies with time. I told you modulus dn upon dt. And from while deriving the Force-Holding law, but we know that modulus dn is equal to lambda n t dt, lambda n t dt, and hence RT is equal to lambda n t dt upon dt. So RT comes equal to lambda n t, simple. If you know decay constant and the number of radioactive nuclei at any time, you can find out RT. Simple. RT is equal to lambda n t. RT is the number of radioactive decay taking place per unit time from the given sample. Further, you know what RT is equal to also NT is equal to, you know, is N0 e to the power minus lambda t. So you can write RT as lambda N0 e to the power minus lambda t, or lambda into N0. Lambda into N0 is equal to R0, means initial rate of activity. Initial rate of activity, and therefore you can write RT equal to R0 e to the power minus lambda t. This equation again shows that RT decreases with time. Decreases with time. I hope you have got my point. Minus lambda n t. As t increases, lambda magnitude of lambda t increases and e to the power minus lambda decreases. If we draw graph between RT and RT, it is R0 here, initial rate, which is equal to R0, lambda n0. Lambda decay constant here. Again, lambda is decay constant here. So we get the curve like this. Again, R0, 0 by 2 here. So this time again T half. So T half again may be defined as the time interval in which rate of radioactivity reduced to half. Simple. You can write yourself. The time interval in which the rate of radioactivity of given sample is reduced to half is called half-life period also again. So you can define it, and the same way you can establish relation RT बराबर R0 by 2 और ये R0 और ये e to the power minus lambda t half. So here again cancel. So we get 1 by 2 equal to e to the power minus lambda t half, or e to the power lambda t half is equal to 1 by 2 equal to 2, or lambda into t half is equal to log of 2 on base e, which is 0.693. The same way. So you again get here के T half equal to 0.693 upon ये 0.693 है या 963 है, सॉरी 1 मिनट का थोड़ा सा कई बार डाउट क्रिएट होता है तो वो गलत नहीं आना चाहिए। ठीक है 0.693 ठीक है। तो दिस वे इट इज द रेट ऑफ रेडियोएक्टिविटी नाउ। तो रेट ऑफ रेडियोएक्टिविटी डिक्रीजिंग विथ टाइम, तो नंबर ऑफ डिके टेकिंग प्लेस है ना भाई पर टाइम। नाउ radioactivity also changing to and decreasing with time. So here you can write one thing more, d upon dt of RT, ये क्या होगा, rate of change of radioactivity, rate of change of radioactivity। So how to obtain here, it is d upon dt of RT is equal to d upon dt of lambda n0 e to the power minus lambda t half minus lambda t. So it comes out to be lambda n0 into d upon dt of e to the power minus lambda t. I hope you remember d upon dt of e to the power d upon dt of e to the power x. It is e to the power x, but d upon dt of e to the power ax is equal to a into e to the power ax. Remember it. So here you can write it as क्या भाई, d upon dt of RT. What is this? Rate of change of radioactivity is equal to lambda square n0, क्योंकि लैम्बडा फिर आएगा माइनस भी आएगा यहाँ माइनस है भाई, और e to the power minus lambda t 1 upon lambda 0.693 t half square and 0. So at a given time, so there was a question once के so that rate of change of radioactivity inversely proportional to square of half life period है भाई, rate of decrease of radioactivity is proportional to 1 upon t square, t half square. Now unit of radioactivity, important unit of radioactivity. So the unit, the SI unit, SI unit of rate of radioactivity is becquerel, BAQ लिखते हैं इसको, in the name of becquerel, BCQUE small b लिखने पे becquerel QUERE कुछ नाम है, और 1 becquerel means 1 BQ लिखते हैं सॉरी, 1 becquerel means 1 disintegration per second, 1 disintegration या 1 decay कर लीजिए, 1 decay per second। अगर कोई एक न्यूक्लियस एक सेकंड में एक बार टूट रहा है तो 1 becquerel, बट इट इज वेरी स्मॉल यूनिट। द बिगर यूनिट ऑफ एक्टिविटी practically is curie, a bigger unit of rate of radioactivity is curie, CURIE, capital C small I, and 1 curie means 3.7 into 10 to the power 7, 10 becquerel, or 10 this इंटीग्रेशन पर सेकेंड। 1 मिली क्यूरी भी यूज करते हैं, 3.7 into 10 to the power 7 BQ। This is very important topic for all exams. Rate of radioactivity, decay constant, half-life. Generally in board exam question comes define half-life period and time and decay constant. Sometimes they ask and derive the relation between them, and sometimes they ask कि write the relation। तो write the relation simple है कि T equal to P half equal to 0.693 upon lambda, और अगर ड्राइव करना है तो फिर यू हैव टू गो टू रदरफोर्ड सोडिला, और यू हैव टू गो टू रेट ऑफ रिएक्शन। नाउ इन कमिंग वीडियोज आई विल बी टेलिंग यू न्यूमेरिकल्स बेस्ड ऑन रदरफोर्ड सोडिला, रेट ऑफ रेडियोएक्टिविटी एटसेट्रा। सो प्लीज इफ यू feel good, then please like the videos, it will encourage me, and share the video, ask your friend please to subscribe my channel. Thank you.